everyone, in this assignment we designed a mobile phone charger and the circuit is designed by using LTSpice simulator with the graph of voltage and current included. The major part of the circuit design is rectification, stepping down the voltage, the filtration and also voltage regulation. The calculation part will be discussed by Kaviraj and Basil.
Okay, I'm going to explain briefly on how the circuit diagram works. Okay, here we use a 240 volts input. So we need a step-down transformer. We use a 12 volts step-down transformer. So after this transformer, we have a bridge rectifier with 4 diodes. How it works is, during the positive cycle of the sinusoidal wave, D2 and D3 will be forward biased, while D1 and D4 will be reverse biased. And during the negative half cycle, D1 and D4 will be forward biased, while D2 and D3 will be reverse biased. So after the output, we have to filter with a capacitor. So that is the work of this capacitor here. Then we have to use a 5 volts regulator to regulate it to 5 volts, since what we need is 5 volts voltage. And this resistor here is the load resistance. Thank you.
The calculation involved in the design of the circuit. So first calculation involved is the transformer. This is the formula for the transformer, where the number of primary coil divided by number of secondary coil equals to the voltage of primary divided by voltage of secondary. As this is the formula for inductance. Using both this formula, we can derive this formula. So using this formula, we input 240 voltage as the input value and the output voltage is 12 volts. So we can get the ratio of the primary inductance and secondary inductance as 400/1. Then we multiply with 300, we can get 120 kilo Henry and 300 Henry for the primary inductance and the secondary inductance respectively. And using the using this formula, we can get the number of turns of the coil ratio, which is 21, which is we are using here. To calculate the capacitance, we have to multiply square root 2 with 12 voltage to get the Vpeak, which is 16.11. Then each diode will use 0.7 voltage during the rectification. So for each process, we have to minus with 2 times 0.7 with 16.11, which will get 14.71 voltage. Then that one we'll have to minus with the regulator voltage, which is 7 voltage. So we get 7.71 voltage here.
1.
So this is the capacitance formula for the capacitor, which is Q over V. Q equals to IT, so divide with V. And the it is already specified in the question, which is 2 ampere. And the time, using this graph, the initial is 50 Hz, after rectified it's 100 Hz, so the time will be 10 millisecond. We input the 10 millisecond and we input the voltage, we calculate over that. So we can get 2.594 millifarad, which is approximately equals to 2500 microfarad, which we will input in this circuit. And after this process, the output voltage will be 5 voltage and the graph will be like this. It will be a straight line graph, which is a DC graph.